Assalamualaikum and good morning. Today I will show you the belt friction apparatus. It is the second experiment for tribology. So it consists of a pulley and a column and a base. So it is using the concept of a pulley. When you have a pulley, you must have a belt. This is a ham rope, and another type of belt is flat belt, like this, flat leather belt. Okay. The belt is attached to a spring balance by a clamp. The spring balance is to measure the forces that acting on the rope or belt. So, in order to make measurement, you must put the rope onto the pulley like this and attach the spring balance at its attachment. So in actual, you must, on the other side of spring balance, which is F1, you attach to, you lock it with this threaded pulley, threaded holder like this. But because this is heavy, you must, it is dangerous to use by a single person. You must, if in the experiment for safety, you must ask the technician to set up for you, because this is heavy. Once you unlock it, it can go straight down and will hurt the student. So another thing that I want to show you is the angle. This is the area of contact for initially. This is 180 degree. As you can see, the angle of contact is 180 degree. So you can adjust the angle of contact by releasing the lock pin at the back, whereby one hole is equal to 15 degrees. So in order to get easy data, we change to 2 hole, which is 30 degrees, angle of 30 degrees. Now the angle is 180 minus 30, it will become 150 degrees up of contact. So you can, later on my friend will show you the actual experiment data, how to do the experiment.
So this is the setup for our second experiment. So as you can see here, our spring balance here shows the initial reading of 50 Newton, and the arc of contact here is, we set it to 180 degrees. So the arc of contact is 180 degrees, and we are using the ham rope as our pulley belt. Okay, so it is a very simple experiment. We just need to turn the hand wheel here at a constant speed, so that we will get the reading of F1 and also F2. Okay, so as I showed you previously, just now, the initial setting should be 50 Newton. So let's move our pulley. So what we need to do is, we are going to turn the hand wheel at a constant speed and get a reading of our F1 and also F2. So let's move our pulley, and we have our F1 reading here and also F2 reading here. So based on these two readings, we can find the coefficient of friction of this particular hem rope using Capstan equation. So the Capstan equation you can find in the internet, and it is totally different from what we had done previously in our first experiment. Now we set that the arc of the contact is 180 degrees. Now we just change the arc of contact from 180 degrees to 150 degrees. So we are going to find out what is the reading of F1 and F2, and after that we are going to find the coefficient of friction of this particular hand rope. So I'm going to move the hand wheel here at a constant speed, and I'm going to give you the reading of F1 and also F2 in the result section. So for discussion number 1, what I need you to do is to find out the coefficient of friction of this hand rope using Capstan equation, and compare it with another data that we are also giving to you in result section, which is the ladder rope. And also for this particular ladder rope, you have to find out the coefficient of friction using Capstan equation.